What words were those? Maybe in a minute. Anybody got any cheese fries? All right. Please make sure you have your learning target written down. I can use the Pythagorean theorem and its converse. What does the word converse mean?
Yeah, I was fixing to say that, but then I realized I don't want to do that because I'm sitting too close to her.
I thought you were talking about the closed shape.
That's convex.
Oh, then you mean it goes out.
That's convex. That one's concave. The converse of something.
Oh, the opposite.
Opposite. Awesome. Good. Take a point.
I said it right when Cameron said it, so we both confused.
All right. So, what is the Pythagorean theorem? And when do we use the Pythagorean theorem?
With triangles.
What type of triangle?
Right triangle.
Only with right triangles. So let's write that. Use only
Oh, my name.
with right.
Theory.
Yes.
Between Thomas Duran to Miss Hayes' office, C102.
Yes.
Thank you.
It's like,
I kind of.
it's like going
It's-
downstairs.
Yeah. Go
You
downstairs.
don't want me to go all the way around.
Don't, hollering at him ain't gonna help. Go down the stairs to the rotunda and go left and then take a left.
I thought they knew we were eating food. I thought they were going to those and be like, stop eating food.
What did you tell me?
Stop eating crap in high school.
Recording all of that, guys.
Yeah, I was thinking that, but I was just going to go for it.
Okay, so you use it only with right triangles. Please draw a right triangle right here for me. How do we know that it's a right triangle?
Because it has a
We have to have the box. Alright, now we have two legs and a hypotenuse. Which one is the hypotenuse?
The long one.
both. This one.
One opposite from the right angle.
Yes, take a point. So this is our C, and the other two would be A and B, and it doesn't matter which one is which. So you're you have to square them, and you get C squared. And normally we would do a really awesome activity, but we don't have time.
Why not?
It is, because we get to prove it, and we get to use it with squares, and you get to count the area, and it's awesome. All right, so A is a leg.
Leg.
It is the leg of the triangle. Is B also a leg, or is B the hypotenuse?
Yes.
B is a leg.
And C's the hypotenuse.
And C is the hypotenuse.
The leg.
Is the hypotenuse the longest side of a right triangle?
Yeah.
Good. Do y'all know how to spell hypotenuse?
No.
Yes.
It's like hippopotamus, but
It's not.
It bounces off.
Are you listening?
I'm listening to you.
Okay, good.
I know.
I always listen to you. I just sometimes ignore you.
So you don't
always listen to
Listening and ignoring.
Oh,
Just ignoring doesn't mean I'm not listening.
I hate when that asks like somebody like, "Are you ignoring me?" And they're like, "No."
Say it again. HYPOT.
HYPOT. E-N-S.
Yes. Good. All right. Hypotenuse. Let's write it in here. Let's see if we can spell it in here. I can do this. Also, Drake, take a point. Good job.
Same. That's my.
All right. So now, what we're going to do today is we're going to talk about how we would use the Pythagorean theorem to find a missing side length, and then we're going to talk about triples, and then we're going to do the converse. So there's two ways that you can do it that I could ask you. You could solve it to the nearest tenth, or you could solve it doing simplest radical form, which we've talked about before, and I hope you still have your note card, because you're going to need this. Now, let's do to the nearest tenth. Please put a little box right there. Right here? Yeah, we're going to do A first. We're going to do it to the nearest tenth. And then we're going to call this X. This is going to be 9.4 centimeters. And this side is going to be 14 centimeters. And we're going to stop talking because I'm teaching. Justin, do you need to go sit in the hallway? Then stop talking. No. Alright, so you plug it into Pythagorean theorem when you're looking for a missing side length. You have a squared plus b squared equals c squared. What is our a squared?
14 centimeters. That's the wrong side.
Okay, so we would write it as x squared plus 9.4 squared equals 14 squared.
So your A is always going to be your X.
That doesn't have to be.
I have a question.
Mm-hmm. Are you sure?
Yeah.
Okay. Alright, what is 9.4 squared? What?
88.36.
But you can round that to 88.4.
Okay, 88.4. And what's 14 squared? Alright, what would we do from here?
Subtract 88.4 from 1
Good, take a point. And what's 196 minus 88.4? 107.6? Okay. That's fine. What can't you see?
Well, it's like the angle is the glare's catching where you're writing, and it's not.
Okay. No worries. Now, how do I get rid of a squared? Square root.
Look at us go.
It's like we've learned something. Alright, what's the square root of 107.6? 10.4. 10.4 what? Centimeters. How do we feel?
Alright.
That's easy peasy?
Lemon squeezy.
Good. You're just solving equations, right?
Yes.
And then don't forget, you have to take the square root here. Do not divide by 2. Do not divide by 2. Do not divide by 2. You have to take the square root. That is not 2x. Okay. Now for the next one we're going to do, are we ready or do we need a mo? Okay, so this time we're going to leave it in simplest radical form. Put a box right here. Alright. This is going to be x. This is going to be 8 inches. And our hypotenuse is going to be 12 inches. Now, simplest radical form means you need to find the biggest perfect square that divides into it. And since I'm sure we've lost our note card, I'll put mine on the board. But can you do what? Good. All right. Can somebody help me set up the equation?
8 squared plus 8 squared
Equals. You're just muttering.
equals.
Okay. Thank you. Good. Take a point. Now, does it matter if we put x for a or b? No, because it's a leg. We don't care which leg it is. It's a leg. We don't. That part doesn't matter. All right. What's 8 squared? What is 8 squared? 64. What is 12 squared? All right, if we subtract those, what do we get?
80.
Good. And then we have to do what? Take the square root. All right, I'm gonna put my card on the board. Remember, we're using our second column. What is the biggest perfect square that divides into 80? Don't say 4. It's got to be bigger than 4. That's not a perfect square. Let's look at the second column up there, the pinkish column. Let's look at that one and pick a number from that. 16. Look at you go. Take a point. What is 80 divided by 16?
5.
Okay. So you get 16 and 5. Who can tell me what the square root of 16 is? Somebody's muttering it.
4.
4. So you leave it as 4 root 5 inches. Ta-da.
See, that part's confusing.
Why? No. Sometimes I want it in simplest radical form.
Oh, it's not easy. I think that was it.
But it's really not that difficult. You just find the biggest perfect square. Now, there are some cases where you have perfect side lengths and you don't have to round or take the biggest perfect square. And we're going to write those on the back, and it's called a triple. You are going to need to know these. It's super easy. All right, Pythagorean triples.
I want to make it colorful.
Do it, Rebel.
So look at you go.
It's like I'm a ninja. I did. It's on the opposite side of this doohickey.
That's nice.
Ninja skills.
Are we ready? Or do we still need a moment to make it pretty?
Stop on it, stop. Someone has some questions.
What was it?
Sunflower.
Sunflower seeds. Who the ham sandwich has sunflower seeds in
Oh, wait,
here?
no, last time. I'm trying to
It's
tell
not
you
me, I
she
got hot
don't
fries, so
listen
you stop it.
I'm trying to tell her.
I don't. You have been talking to me too much since 7 o'clock this morning. I can't listen to you for that long.
I was telling her, I was like, hey, there's sunflowers that could be here.
Early. I don't. We moved. I live in Chelsea now. All right. So there are 4 types of triples. You have 3, 4, 5. Which is the first type. You survived. 5, 12, 13, 8, 15, 17, and the last one is 7, 24, 25. Now, what a triple is if you do 3 squared plus 4 squared, it's going to equal 5 squared. So what's 3 squared?
9.
What's 4 squared?
16.
What's 5 squared?
45.
What is 9 plus 16?
45.
Ta-da! That's triple. I know. Isn't it awesome? And the great part about it is you can do the multiples. So it's a squared plus b squared equals c squared. That's a triple. And this is your a, b, and c. The biggest side is always your c. Because it's your hypotenuse. All right, what's 5 squared?
25.
Okay, what's 12 squared?
144.
What's 13 squared?
169.
Alright, what's 25 plus 144? Ta-da!
Why is 7?
I don't need no Wi-Fi. We could have just added this. I'm so sure.
Isn't it great though?
Why did the 7 come after the 8?
What?
Wait. Okay.
What?
This is
Okay,
what-
BC 8, 15, 17. 7, 27, 25. Why did the 7 come after
Different.
the 8?
It's different. It's just a whole different.
It's just a different triple.
Oh, alright.
It's not that deep, man.
It's not. It is not that deep. You can also multiply these by 2, and that'll give you a triple. So what is 3 times 2? What is 4 times 2? What is 5 times 2? That's a triple. You can do. I know. What is 5 times 2? 12 times 2? 13 times 2? That's a triple. What about 8 times 2?
Oh, baby, a triple.
That's exactly what I was thinking.
Oh, Jesus.
I don't even know how to feel right now. What is 17 times 2?
34.
I really don't understand what you're doing.
Me? I'm just multiplying each of my numbers by 2.
Yeah, but like, what is a triple? Like, don't you saying that's a I don't understand.
A squared plus B squared equals C squared. So if I do 5 squared, I get 25. Okay? If I do 12 squared, I get 144. If I add those two together, it's going to be 169.
And that's our answer.
And that's your answer. That's a triple. Those are your side lengths. Yeah. And I just want you to multiply by 2.
Wait, so we don't even have to do Pythagorean theorem.
If you have these two numbers, you don't have to do the Pythagorean theorem, it's going to be 5. If you have these two numbers, you don't have to do the Pythagorean theorem, it's going to be 5. If you had 8 and 17, you don't have to do the Pythagorean theorem, it's going to be 15. So it is important to know your triples.
Does that work for the blue
No, your
numbers, too?
triples, man.
Does it work for the blue numbers too? Like
Yeah.
6 and 8, then we don't. and then
Yep.
That's crazy.
I know.
What?
So you could do 14, 48, and 50. That's a triple.
I wish I knew. And it goes on and on.
Oh, I get
And it goes on and on. So your formula for this specific triple right here is 3x, 4x, and 5x. Your formula for this one would be 5x, 12x, 13x. Your formula here, 8x, 15x, 17x. So any multiple of your triple makes a triple, and you don't have to find your sides. You don't have to use the Pythagorean theorem.
Things like this is what makes me believe Illuminati, bro. This is the true.
So if it's
threes.
but if it's not a triple, what would you have to do?
It would not be.
You would have to use the Pythagorean theorem. But luckily, this is a triple. These are triples. So if I gave you, I know, this.
I don't understand why nobody showed me this like when I was studying.
Right?
Pythagorean
This
theorem.
is so much easier.
They be holding
Teachers
thumbs back.
want you to struggle.
It's not that we want you to struggle. It's that we want you to learn how to constructive struggle and not give up and be able to work. Because that's what like the rest of your life is.
I'd rather not.
Only constructive.
The rest of your life.
But if you would just learn the easier way first, then no one would ever quit because it would just be.
That is not a true statement.
Yeah, I know.
That is
But
not
still,
a
I
true
would have.
statement.
Like I gave up on Pythagorean theorem like a long time ago, and now I feel like it was pointless because.
I'm just gonna do the
What if
whole
your
thing.
parents always told you to give up something quick?
He got bad parents.
Okay, we're ignoring that, and we're going to this problem. What triple is this? All right, so what would x be?
Here.
Boom, and you're done with that problem.
Is X always going to be 5?
No, it just depends on the triple.
So it doesn't matter what order they're in or
What?
It's just be like the third number is that number.
Yeah, the biggest number does have to be C. It does have to be across from your 90-degree angle. So if 13 was right here and 12 was here, that would not be. 1, it wouldn't be a right triangle. If it was 12 and 5 right, how did I do this?
144 plus
Okay,
45
hold on.
equals-
Everybody breathe. Breathe. If I had 5 and 12 here, this would be 13. Is that what you're asking? Because Christian's freaking out and I can't
So like if I would have had 5 there instead of 12, it would still be 12.
Right here?
Yeah.
Yes, this would be 12 because it's part of that triple. Now, how I did that was I saw that I have 12 and 13, and I said, self, is that part of a triple? It is. And what's the missing side length of that triple?
So those are the only triples that exist. There's no other ones, and I can just stay with those.
3x, 4x, 5x. So if you multiplied 3 by 5, 15, 20, and 25 would be a triple.
If triples
I know, but all the ones up there, those are all the triples that ever exist.
Now, you could also do x squared plus 12 squared equals 13 squared. And let's do this to prove it for you naysayers that are freaking out and having a heart attack. All right, what is 12 squared?
144.
What is 13 squared?
169.
Okay, what would I do from here?
Subtract.
Subtract, and I get x squared equals, what's 169 minus 144? 25. All right, what's the square root of 25?
Illuminati exists.
I've reached my peak of like how much math I can take.
You got a whole other year, honey.
Oh, I'm done.
I think I just need it.
It's not scary at
Triples go
all.
on forever and ever. How are those
Illuminati is not scary.
The pattern.
It's scary.
It works.
Okay, draw this one.
I don't know if I can handle this.
Persevere in the face of danger.
Oh, where's
You're
Megan?
gonna ask me why did you do that? Like, you ever
really
heard of
ugly,
triples?
Miss Asbury blew my mind. I couldn't take anymore.
Does it matter if it's turned at all?
So I just turn mine. It looks like almost like mine.
I'm just tracing the limits on the console.
Y'all are ridiculous. You know that, right?
Yes, ma'am.
Okay.
You're a triple.
What?
6 feet in J's.
Yeah, that's a
I mean, you alright.
That's so scary.
All right, 16 and 34.
It's 30.
Why?
Because it's our triple.
That's our triple.
No.
What?
I was just about to say
No.
That's it. That's all you do.
Whoa.
Yeah, I am.
magnificent mom, bro.
This is a little too much for me right now. Like, I can't handle this. There's a lot going on in my life.
My triangle looks like a Dorito.
Dude, it looks perfect.
Okay. I don't know what to do with y'all anymore. So it's beautiful.
Just feed us and tell us we're pretty.
How about y'all do that for me? Okay, baby. All right. It's a
You
triple.
really want all
Okay.
of us to feed you and pet
So
you?
this is 16 and 34. And we went through our beautiful list of triples. And we looked for 16 and 34. Where do you see 16 and 34? Nat, let him do it.
Right there.
Where's right there?
Or the 8, 15, and 16.
So the third column in the second row. What is the missing piece?
30.
Ta-da!
It's like Dora when it's like,
Yeah.
can you find boots?
Wait, and we're gonna use the same triples every time?
No, that's if it's a triple.
I don't know.
Wait, so
Right.
if it okay, guys. Okay.
But he just asked, are we going to use the figures? She said,
I know what he asked, and now I'm taking a moment to breathe and go back and flip my paper. Now, do you see how this was 8 and 12? Okay, 8 and 12. Are those, is 12 a hypotenuse in any one of these? Okay, so what did we use to solve that?
Pythagorean.
Yes. So if it's not a triple, use the Pythagorean theorem to find your missing side length. This is just the beautiful pattern that happens when you have perfect numbers that go together. So if you don't have the perfect numbers, if I gave you one like this. Yep. Draw this. I need more. I need more.
I will stand there and hold the book.
No, it's fine, baby. Thank you. Draw this, please.
Give your mom what they want, or else they like go crazy. Kind of scary.
Okay, I have X, 9, and 11. Now, is 11 any part of our triples up there?
No.
No. So we can't use a triple. So to find the missing side length, we're going to use the Pythagorean theorem. And what is the Pythagorean theorem?
A squared plus B squared equals C squared.
Okay, how do we know what to plug in where?
I'm spitting.
The new legs aren't C.
Okay, so we're going to do X squared
Plus 9.
plus 9 squared equals 11 squared. Put your head down. Put your head down. Yes, put your head down. There. All right, 9 squared is,
81.
okay, 11 squared is,
Ain't that serious?
see what I'm doing? Okay, now what would I do from here?
Subtract you.
Okay, and you get X squared equals what?
40.
And now what would we do? Take the square root. I want it in simple radical form. What's the biggest perfect square that goes into 40?
8. 8 and 5.
8 is not a perfect square.
4.
4 and what? Okay.
Oh yeah.
That'll be 4 root 2.
What's the square root of 4? 2. So remember, when you break it down to perfect square, you have to look back to the left. 2 root 10. Good. Because we've done square roots before.
Okay, so if it has 3 numbers, it's a triple. And if it doesn't, we have to do.
No, baby. No. If it fits this pattern, it's a triple.
Oh, okay.
If it doesn't, we use the Pythagorean theorem.
I got it.
Are you sure?
Yeah, I got it now.
Does everybody understand now?
Yes.
Okay. Can we flip back to our notes and talk about the converse, or we think it might blow our mind?
It might
I mean, as long as we don't pull out anymore, like stunts. Just so you know, we got 4 minutes. Yeah.
I got this.
You got 4 minutes to blow our minds. I have faith in you.
Thanks, guys. Thanks. All right. It's when it's straight, it's so long, and it's.
That's what
I'm kind
I'm
of
kind of upset that like
without
you're
my
doing your
mom.
hair now because like I'm still not doing mine.
I'm a dye too.
I just wanted to blow dry it. I'm sorry. I won't blow dry it again. All right. So this time the converse, is it a right triangle? So the converse says. The converse says that 3 sides must fit the Pythagorean theorem to be a right triangle. So what we're going to do is I'm going to give you 10, 24, and 26. And to see if it's a right triangle, we're going to plug it into the Pythagorean theorem. That's it. That's all we do. You just plug it into the Pythagorean theorem, which is a squared plus b squared equals c squared. Now, does it matter what we plug into A or B? As long as it's not your hypotenuse, which is 26. So we would do 10 squared plus 24 squared equals 26 squared.
Oh, that's a big number.
All right, what's 10 squared? What's 24 squared?
576.
What is 26 squared? All right, what's 100 plus 576?
277.
Are those the same thing? Boom, it's a right triangle.
Boom. Whenever I get big numbers in math, I feel like I did something.
Don't be afraid. Who taught y'all to be afraid of big numbers and decimals? Stop it. Don't be afraid of them.
It was like, that number's too big. Well, how'd you get that?
I do what I'm supposed to.
We are not afraid of big numbers or decimals. All right, now,
Basically, any teacher that wasn't me.
if this is a true, blah blah blah. When you work out a squared plus b squared, if it's less than c squared, it's an obtuse triangle. If it's greater than, it's an acute. For homework tonight, I want you to work out these two. And una más. 8, 6, 11. I want you to do this one, and this one. So 3 problems for homework. These 2 and here. Check I now. If you are not passing my class, you have to come to 0 period or send me some kind of email of things that you were missing. Does everybody understand? It is not my fault that you do not turn in your work.